Geographers, hello, welcome to the course, Kev here. The first topic that you're doing with me is coastal landscapes and change, alright? Now your first lesson with me this week, we had a look at the different components within the littoral zone, such as the backshore, the nearshore, the offshore, the foreshore, and then we went on from there to think about how coastal environments are dynamic and they're constantly changing, and they have inputs plus processes, and we end up with outputs. Alright, so typical input would be inputs from the ocean, which we can call marine inputs, the atmosphere and climate, people, and geology and rock type. So it's kind of what's there, yeah? If we then add to that different processes, we can think, well, what is the dominant process or processes along a particular stretch of coast or a coastal environment? So your 3 or 4 main processes are erosion, transportation of sediment, and deposition. Also weathering and mass movement as well, if you want to get a bit techie. When you combine your inputs and your processes, then you get your outputs, which we looked at last lesson, the different types of coasts, from sandy coasts, estuarine coasts, or rocky coasts. And this lesson kind of leads on from that, alright? So what we're going to learn is how, as geographers, we can classify different stretches of coast, because there's lots of different criteria really, and we're not actually going to cover all the criteria because I don't think it's needed to be able to actually understand what you need to understand and perform well in the exam. But the ones that we do cover, we're going to need to know them well. Alright, so if you look at the spec, we are going to cover 2.1 B, C, and A. We're going to touch on A in this video lesson. Alright, so what you're going to learn is to understand the different ways coastal environments and landscapes can be classified. We're going to name some examples, because as geographers, it's fantastic understanding the theory, but we also need to kind of, where's this happening? Yeah, so in your notes you need to be jotting down some examples, and then we're going to link some of these classification and examples and actually look at, well, what do you end up with? What are your typical landforms in these different kind of environments? Alright, the idea with these videos is that you don't just watch them, yeah. Obviously watching them's a good start, but you need to be making notes. You can be doing sketches of things, try and keep your notes organised as well. If you find that the first time through they're a bit messy because you were getting the hang of kind of pausing, playing back, if you've missed something and it's a bit disjointed, then I'd probably advise that you write them up neat. Alright, so give your nice shiny new sheet aligned paper a title, just put classification of coasts, and then we're ready to go. Alright, okay then, the first way that we can classify coasts is by the level of energy. Alright, and coasts can primarily be low energy environments, like what you see in the photograph to the left. This is the Humber estuary, which generally speaking it is quite a sheltered environment, because Spurn Point, which is a spit or a hook spit at the mouth of that estuary, shelters the Humber estuary from high energy shocks from the North Sea. It shelters it. Alright, so waves, the type of waves that we find in these low energy environments, tend not to be too powerful. Alright, that doesn't mean to say though that you don't get high energy shocks sometimes. So like I said, these classifications are general. Alright, it's probably wrong to say that all low energy coasts never have a high energy input, because sometimes they might do, in such as cases of a winter storm, for example. All right, they tend to be sheltered, like we just mentioned, by spits or by headlands, and we'll cover them in more detail later on in the course. Now, if we think about as coastal system having inputs, processes and outputs, then normally, because we've got low energy waves, the rate of deposition, so sand and sediment, we tend to get more being deposited than what's being removed by erosion. And you can see that in this photograph on the left. Yeah, mud flats, we get deposition of landforms like wide beaches, spits, sand dunes, salt marsh, and you can see that in the photograph. Also, these environments tend to be gently sloped towards the sea, all right, and they tend to be coastal plain environments. However, because deposition is normally the dominant process and they're kind of used to being sheltered, they are vulnerable to erosion from any high energy shocks, such as from storms, all right. On the other side, we've got Connacher, this cliff. It's the tallest sea cliff in the UK, and I will type it in for you, e.g. Connacher, and it's in the Outer Hebrides, which is off the northwest coast of Scotland, and this sea cliff is 427 metres tall, and as you can see from this photograph, it is pretty steep, practically vertical. All right, so little case study example for you. And because it's facing the Atlantic Ocean, it's very exposed environment. High energy destructive waves, very powerful waves, break at the base of the cliff, at the foot of the cliff, and that's, for significant parts of the year. There are days when it will be kind of calmer, but generally speaking, very exposed to a large fetch. High energy, powerful, destructive waves constantly trying to erode the base of the cliff. All right. So the rate of erosion is greater than the rate of deposition. Yep. And what type of landforms do we get? Well, they tend to be steep cliffs. So the harder and the more resistant the geology, the steeper the cliffs tend to be. All right. Now, high energy coasts, we can also end up with kind of more sloped, curved cliffs like at Holderness, but I'm not going to get too bogged down by that at the minute, because we'll cover that in more detail in future lessons. So low energy, high energy. All right. The second classification that we can use is we can classify coasts according to their geology. And we're going to introduce, like I said, some other key terms in future lessons, such as lithology, geological structure, and faults and folds and things like that. But this lesson, I just want to keep it quite simple. Yeah. So we can either have a very resistant geology that's resistant to erosion, like at Connacher. Yeah. Very resistant metamorphic and igneous rocks, which are really hard. Now, they resist erosion, all right? Because the geology is that resistant, even high energy inputs from the sea and destructive and powerful waves, aren't that successful in eroding this coastline quickly, all right? Even with the high energy inputs, erosion rates at Connacher are way less than a centimetre per year. Yeah. So the more resistant the geology, the steeper and taller the cliff in general. On the right hand side of your picture, we've got two coastal environments where it's the opposite basically. The lithology or the geology is very soft. It's easily eroded. It's more easily transported and deposited. So in the bottom picture, you've got a sandy coastline, all right, and in the top right picture, it's the photograph from before at the Humber estuary, where an estuary is where the rivers input into the ocean, and towards the mouth of the river, it's got a high tidal influence, all right? So an estuary is where basically the ocean and the river meets, where the tidal influence is significant. So you've got an input from rivers. You've also got an input from the sea in the form of the tides. Yep. Generally speaking, again, if you get softer, sandy lithology, such as clays and sands, you tend to get flatter, more gently sloped coastal plains. All right. The harder the lithology, the steeper and taller the cliffs. Focusing still on the classification using geology, we can also think about how rock and geology is kind of aligned. How is it aligned in relation to the ocean? So there's two types primarily. The one on the left is called a concordant coast, and that is basically where you've got bands of rock alternating between hard and soft rock, and these bands of rock are in line with the coast. So they run parallel to the coastline, all right? On the right-hand side, you can see if the sea is here where my cursor is, and the waves approaching from, in this example, right to left, if you like, the bands of lithology aren't parallel with the coast, but they're at 90 degrees to the coastline. So you could say the perpendicular, right? So you've got hard rock, just here. It won't let me draw. Forget that. Yeah, so hard rock that's green, then soft, then hard, then soft, then hard. And they're at 90 degrees to this coastline. On the left, you've got hard rock, hard rock, but they are parallel to the coastline. And in lesson, we're going to look at what effect that has on landforms. I'm not going to spoil the surprise now, folks, but yeah, we'll do that in lesson. The third the third way we can classify coasts is by the dominant process. So the previous 2 or 3 slides, if you think about as coastal system, the previous 3 slides, which was energy and geology, they are inputs into the system. The third one, it's kind of classifying the coast by the dominant process. So it's the balance between erosion of material, which is the removal of it, versus deposition. And we can also use the word accretion as well. The meaning of the word accretion is if you're adding something, all right? Accountants can use it, and they use the term accruals if they're adding money to the books, for instance. But yeah, is the dominant process one of erosion, where destructive waves or tides are removing material, or is it one of deposition, where sediment is being deposited and it's accruing, if you like? And general patterns are that high energy destructive waves, such as at Connacht Air, erosion is the dominant process, all right? In low energy sheltered environments where we get constructive waves, deposition and accretion is dominant. Now that then affects what outputs you get. So what do you actually see? What do you end up with? What's the result? Well, just like at Connacher in the Outer Hebrides, erosional features and landforms tend to be steep sea cliffs, stacks, caves, wave-cut platforms, and others such as blowholes and geos. Whereas if accretion or deposition is the dominant process, we tend to get wide sandy beaches. If it's sheltered, then we get lagoons and spits and barrier islands. All these different landforms, we study their formation in detail, so don't worry too much if there seems to be a lot and it's kind of coming thick and fast. Yeah. The fourth way we can categorise coasts is by thinking about the sea levels and whether the sea levels are rising or falling. Now, there's two types that we're concerned with. If sea levels are rising or land locally is sinking, then we'd say that that coastline is submergent or submerging. Just like when I go on holiday with my girlfriend, we're in the pool together and she can be nasty, so sometimes she comes up behind me and dunks me. Yep, so you could say that I'm submerged at that point because I'm underwater, not quite drowned, that'd be a bit brutal, but yeah. You can say that the coastlines are flooded, drowned, submerged, and we get features and landforms such as rias and fjords. If you came to induction, I think we touched on rias and fjords briefly, and we look at them in more detail in future lessons. On the right hand, in the right hand picture, we've got an example of an emergent coast, and that's where the land locally, just in this location, is rising, and it's actually rising faster than sea levels are rising. So it's almost like this land mass here is popping out of the sea. It's moving upwards, yeah. And you can see what impact that has if you look at this photograph, because it's kind of left a series of tide marks where sea levels were previously. So 5,000 years ago, if you were walking along this coastline, the sea level would be where my cursor is. 2,300 years ago, it was just here, and you can see that the land over time has been popping up or rising, emerging out of the water. Alright. The example of the submergent coast on the left, in the left-hand photograph, is the St. George's River in Sydney. I'll type that in for you. Yeah, the St. George's River in Sydney, Australia, and the example of an emergent coast on the right hand side is Turakirai Head in New Zealand. It is a bit of a mouthful, and it is tricky to spell. So yeah, Turakirai Head in New Zealand. And just to end, folks, it's just a bit of a kind of a warning, really. Just be a little bit careful, because these classifications, such as geology, energy, dominant process, and whether sea levels are rising or falling, they are useful to us because they give us a framework for kind of understanding what's happening in coastal environments. So I think what they do well is they kind of let us think, which inputs are kind of happening, how processes then affecting outputs, and they give us a bit of a framework for looking at different kind of factors, if you like, what result in different coastal environments. But as with kind of a lot of things in physical geography and the natural world, although they're useful, beware of kind of boxing things up nice and neat and kind of saying, well, this whole stretch of coast is, a high energy environment with resistant lithology, because not too far away, you might find an example of a coastal plain with a lagoon and a sandy beach, and it might seem a bit confusing. So in reality, geography can be a little bit messy, yeah? And you can find stretches of coast what are kind of very mixed, and you'll go from steep, tall cliffs to coastal plains, back to steep, tall cliffs, and you might be scratching your head a little bit. So a couple of examples just to demonstrate that. Cornwall in general is a high energy coast because it's exposed to the Atlantic Ocean. It's mainly a rocky coastline because it's got resistant metamorphic geology, which is very hard, so it doesn't erode quick. But then it also has estuaries and sheltered parts where the lithology is kind of sand and deposition is the dominant process. So again, that's one example. Example two of where it can get a little bit messy is if you think of the southeast of the UK, it's low-lying, it's flat, you'd describe it as a coastal plain environment. The Thames flows into the North Sea, and that's an estuary, so it's under tidal influence. Very soft lithology, and then literally, you go around the coast of Kent, and you've got the White Cliffs of Dover, which are really tall, and estuaries as well. So yeah, that's another example. Example three, if some of you studied the Holderness coast at GCSE, which I'm probably assuming that some of you might have, to the north you've got resistant hard geology, which is chalk and limestone, so you get kind of steep cliffs, and then it kind of transitions to a softer geology, which is boulder clay, and we'll look at why that is. Why does it kind of switch from resistant geology to very kind of soft geology, and then it changes again where it's really gently sloping and flat when you get to the southern part of the Holderness coast, where you get a depositional landform in the form of Spurn Point. So if you get a photograph in the exam, just say what you see basically, and explain it using your understanding. Don't be scared to make suggestions. All right. Right then. So in time for next lesson, have a neat and comprehensive set of notes. Also, if anything from this video doesn't make sense, then have some good questions ready for me, because the first part of next lesson I'm going to actually spend trying to work out what you actually get, what you don't get, and clearing up any misunderstandings. Alright, thanks for listening folks, have a good one.